Hi, this video is about the relationship between electrical voltage and current in physics. Now, voltage is the difference in electric potential energy or electric potential between 2 points. And then current is how quickly electricity can flow through a circuit. So in order to find the relationship between these two, I need to first find a source of voltage. So I have one here in a battery. A battery provides a difference in electric potential at both ends of the battery. So we have a negative terminal and a positive terminal. We have negative charge stored up here, positive charge stored up here. There's a difference in electric potential, and I need a way to get that charge to flow. So I need something to make a circuit so that it continues to flow like a river through this battery and create a current. So to do that, I can connect it to some kind of circuit. So I'm going to build a little circuit here for you. So I've got my battery here, and I've got a light bulb here, and I want to be able to measure how much current is actually going through my circuit. So I need to also include some kind of meter that will tell me. This is an ammeter. This measures amps. And it's kind of hard to see here. It's got two different scales. It's got a bottom scale and a top scale. So the bottom scale goes from 0 to 1, and the top scale goes from 0 to 5 amps. We're going to be using the bottom scale for this circuit. So I'm going to connect this to my battery. Now this is not going to result in any current yet because I don't have a complete circuit. I need the electric potential to go all the way to the difference in electric potential. So I've got my connection there. I'm going to use this terminal here, connect it to a light bulb. And then I'm going to connect this back to my battery. Oh, I have a switch as well. So this is going to function as my kind of my light switch here. So I'm going to connect that and then connect this back to my battery. Now right now the switch is off, so we should have nothing going through this circuit. Now I'm going to turn the switch on here, and so when I do that, I should see a current. Now if you look at the little ammeter here, you can see the current kind of fluctuating as it stabilizes here. So I've got a current of about, looks like 0.2, a little over 0.2, so maybe like 0.22 amps. And I don't see any light actually in the light bulb. If it's there, it's very faint, but it does say that there's a current going through, so maybe it's just not enough current to create light. So I'm going to record this over here. I have a current of 0.22 amps, but I need to figure out what my voltage was. I already forgot what it was, so that's no problem. I'll just take my voltmeter out and measure between the two ends here. So that is, I need to hold this still. Now it says 1.335. So we have a voltage of 1.335 volts and then a current of 0.22 amps. So to find the relationship, I need to change one of my variables here and see how it affects the other one. So I'm going to be manipulating the voltage. I'm going to up the voltage here. I'm going to turn my switch off. I'm going to disconnect this here. And I'm going to step up the voltage by adding an additional battery to my circuit. Okay, so by doing this, now there's twice as much, well, not twice as much, there are different voltages, but essentially twice as much voltage. I'll have to get the exact amount here because these batteries are old, so they don't have equal amounts of voltage. So now that I have two batteries connected to my light bulb, I'll turn the switch on now. Okay, well now I have a light, okay. And now I have some more current as well. So let me measure my voltage here. Let's get my multimeter out. And now my voltage is at 2.62 volts. So almost doubled there. And my current, I'm reading it at, looks like about 0.3. 30 amps. Okay, I'll turn the switch off and I'm going to add an extra battery here. And I'm making sure to line up the positive and negative terminals so they're going in the same direction. Okay, and I got my battery. And now I'll turn my switch on again. Okay, now it's extra bright light, and we're at about 0.38 amps. And now my voltage, it looks like about 3.3. It's kind of saying 3.32. I'll just call it 3.3. Okay, I'll turn my switch off, and then I'm going to add one more battery. We'll see if it doesn't blow the light bulb out. I don't usually connect more than 3 batteries to these little bulbs, but for the purpose of science, we'll see. Let's get this connected here. Okay, I've got my batteries all kind of chained up here in a row. Got my switch off, so I'll put this, connect this here. And then let's see if the bulb doesn't blow out, what our new voltage and current will be. Oh, we lost connection here. Did I already blow the bulb? Oh, whoa, there it goes. Okay, might have to act fast. Okay, so we have a current of it's hard to read that, 0.45. All right, now it's saying 5.72. Okay, that's a little bit more reliable there. 5.72. Okay, so I've got a voltage and a current. I've got a relationship here. I want to figure out what this relationship is. So to do that, I need to make a graph. That's how we find a relationship in physics. Whoops. Stand by for technical difficulties. I forgot I was hooked up to a microphone and took out my camera there. All right, it's probably a little crooked now. Okay, so let's find the relationship then between voltage and current. So to plot this on a graph, we're going to do y and x-axis here. The manipulated quantity is always going to be on the x-axis, so that's the voltage in this case. And then the current goes on the vertical axis here. So with this data, then I can start to plot my data points here. So 1.3 volts gave us a current of about 0.2. You kind of see a pattern emerging here, and it's a straight line here. I'll draw a line of best fit that tries to go through most of the data. Now with this relationship, we also can make an equation that relates current and voltage. So what we find here is that current is directly proportional to the voltage. So I'm going to use this little symbol here for proportional and then voltage. What we see is that as you increase the voltage, the current goes up by the same factor about. So if you doubled the voltage, you get double the current. And so we can simplify this a little bit with mathematical symbols. So I for current and V for voltage. And we say that they are directly proportional. Now, there is another factor involved here, and that is resistance. So that's our controlled quantity in this experiment that we did. The resistance is how much the current gets obstructed. So it's a measure of just how much obstruction or impedance there is to letting the current going through, to let the current go through. And so resistance is measured in a unit called ohms. And we use a capital omega to represent ohms. And the resistance in a circuit, if you have twice as much resistance, you're going to have half the amount of current. It's another proportional relationship. This time it's inversely proportional. So if you double the resistance, you get half the current. And so to write that in mathematical terms, the current is inversely proportional to the resistance, or in other words, the current is proportional to the inverse of resistance. So we have two relationships here for current, and these are the only two relationships that we've found that matter when it comes to electric current. So current is directly proportional to voltage, proportional to the inverse of the resistance. So if we put these two together, we get a single unified equation. The current is equal to the voltage over the resistance. This is known as Ohm's law. And it's a very simple law that tells us exactly what the relationship is between how much current you get and how much voltage you have across the circuit, and also how much resistance is present in the circuit. So that's all I've got for you in this video. Remember, shortcuts make long delays.